Hello, welcome to BIS Talks. An old saying goes, necessity is the mother of invention. From ancient times, humans identified their needs and therefore made different inventions for their survival. Metals were one such invention which shaped the course of mankind. Over a period of thousands of years, humans learned to identify, extract, blend, and shape various metals into tools, weapons, ornaments, and other useful items. Their impact in the development of human lives has been so profound that the distinct eras, like the Bronze Age and the Iron Age, have been labeled after them. Even today, we find various famous monuments around the globe, such as Eiffel Tower, London Bridge, Howrah Bridge, and Iron Pillar at Qutub Minar, etc., which are made of metals and are known for their beauty, strength, and longevity. These monuments stand as a testimony to the metallurgical sciences known and practiced from ancient times. With the passage of time, a lot of changes and developments have taken place in the production processes of these materials. Over a period of time, different alloys and grades of these metals were also developed to meet the requirements of various applications. In order to avoid the proliferation of different grades of materials and to streamline the quality of products produced by different technologies for promotion of trade and commerce and to emphasize the concept of interchangeability, a need was felt to standardize the process of manufacture, to standardize the different grades of the metals developed, and to standardize the testing of these materials. In India, Metallurgical Engineering Department of Bureau of Indian Standards formulates standards relating to metallurgical engineering field while keeping in view the socio-economic conditions prevailing in the country. Let's listen to Shri N. Surya Narayan, head of this department, to know about the history, structure, and working of the department.
Bureau of Indian Standards has started formulating standards in the field of metallurgical engineering since 1949. And since then nearly 1700 standards have been formulated, out of which 725 are product related standards, 269 are related to code of practice, 523 are related to methods of testing, and 155 are other miscellaneous standards. Standards have been formulated from steel wire used for manufacture of needles to the materials used in the aircrafts. Moreover, it has formulated standards relating to physical testing of materials such as hardness testing, tensile testing, and non-destructive testing of materials such as radiographic testing and ultrasonic testing of materials. The Metallurgical Engineering Department works under the guidance of the Metallurgical Engineering Division Council of BIS. The council consists of 20 technical committees, and these committees formulate standards relating to various fields of metallurgy.
So we now know that the scope of standardization in the field of metallurgy is very vast. Let's hear from Shri Raman Kumar, Chairman of the Council, about its role and functions.
Bureau of Indian Standards, for the purpose of formulation of Indian standards in respect of any goods, articles, processes, systems or services, constitute technical committees of experts known as divisional councils. And Metallurgical Engineering Divisional Council is one such council constituted to formulate the standards in the field of metallurgical engineering. The council consists of 20 technical committees who look after the formulation of Indian standards relating to various areas of metallurgy, right from standards relating to ferrous and non-ferrous metals and their products, powder metallurgy, refractories, ores and minerals, to testing of materials both destructive and non-destructive, nanotechnology and processes such as welding, foundry technology, corrosion protection, etc. The Council advises the Technical Committee on the subject areas to be taken up for formulation of standards, Further, it advises them on matters related to research and development needed for the establishment of new standards or revision of the old ones. It also provides guidance to international standardization organizations and recommends the technical committee to the extent and manner of participation in standardization activities at international level. Moreover, it advises on the implementation and promotion of established Indian standards.
As you now know that Bureau of Indian Standards has formulated about 1,700 standards in different categories of metallurgical engineering. We shall now describe some of the standards formulated in each category. Do you know about the standards specified for channels, beams, angles, rounds and other such products that are used in the construction industry? These products fall under the category of ferrous metallurgy. Let us take a look at the list of some important standards formulated in this category. Now let us hear from Shri Arun Puchakayala, scientist BIS, who talks about some of the standards in this category.
In the category of ferrous metallurgy, the standard IS 1239 Part 1 for steel tubes of sizes ranging from 6 mm to 150 mm covers the requirements of welded and seamless tubes intended for use in supply of water, non-hazardous gases, air and steam. The standard specifies requirements for chemical composition, mechanical properties comprising of tensile strength, elongation, flattening test and bend test and dimensional tolerances of pipes. This standard covers black pipes and galvanized pipes with enhanced resistance for corrosion, which can be supplied with either of one or both ends socketed with or without screw threads. Another standard, IS 2062 for hot rolled medium and high tensile structural steel, covers the requirements of structural steels of various forms ranging from plates to angles. The standard prescribes requirements of chemical composition, mechanical properties comprising of yield strength, tensile strength, elongation, bend test and impact test, and dimensional tolerances for 9 grades of steels classified on basis of yield strength ranging from 250 to 650 megapascals. These grades of structural steel are also subclassified on weldability with improving quality from A to C. This standard IS 6911 for stainless steel sheet and strip comprises of steels that are resistant to corrosion and heat through addition of alloying elements with chromium as principal alloying element. The standard specifies requirements of chemical composition, mechanical properties and dimensional tolerances for various grades of stainless steel mentioned both on basis of designation, numerical symbols prevalent in industrial parlance. The grades mentioned in standard are classified into 4 types on basis of microstructure as ferritic, austenitic, martensitic and duplex, which can be supplied in different finishes catering the needs of industry segment comprising of food and catering, chemical and pharmaceutical appliances, medical equipment manufacturing and architecture and construction. The standard IS 1110-1990 consists of 12 grades of ferrosilicon, which is an alloy of iron and silicon with a typical silicon content by weight of 15 to 95% and used in production of steel. The standard specifies chemical composition including reference method of test for determining composition. In addition, the standard also subclassifies the product on basis of size designation besides defining lots on basis of homogeneity of heat in mixing the product for supply.
Let us have some more details about the standards from Shri Manish Kumar, one of the leading manufacturers of ductile iron pipes used for carrying water and gas. He is also a member of the technical committee that has formulated these standards.
As a pipe manufacturing company, our 2 main products, one is the ductile iron pipes and another is the mild steel pipes. They are primarily used in India for the water application, wastewater application and oil and gas application. For the ductile iron pipes, we are using IS 8329, which is the mother standard for product, that is ductile iron pipes. Then we are using IS 3589, which is for the mild steel pipes. So these are the basic product standards for the two products which I mentioned as ductile iron and mild steel. But for each product there are other standards. In order to explain, I'll just briefly give you the references. For example, when we use ductile iron pipe standard, which is IS 8329, then we have to also use the reference standards. For example, the laying standard of ductile iron pipes. Then we have to use also the standards which are used to measure the different parameters within the dimensions of the pipes, sampling of the pipes, inside lining, outside coating, and then the relevant standard applicable to these linings and coatings. Now similarly for mild steel pipes, when we talk about the mother standard IS 3589, which gives the product's dimensions and the relevant parameters, then again for each type of lining and each type of coating, the various other related standards are also used. Another important point is that the ductile iron pipes are following under the mandatory certifications, which means that this product cannot be sold in India without having the BIS license, and no single product can go out of the factory without the BIS marking. And because BIS also specifies the various tests to be conducted on the product before the product goes out to the consumer, we also have in-house facilities to carry out all the relevant tests which are specified in both the standards. So we have in-house laboratories. Then for each test to be conducted, it is not necessary that all the procedures of the particular test are given in the mother standards. Then we have to follow a number of international standards and the BIS standards in order to complete the manufacturing process and quality requirements. So in totality, in order to produce a product, the number of standards to be referred goes into hundreds. So it's an exhaustive list, but as I mentioned, the two mother standards are IS 3589 and IS 8329.
Well, that was quite informative. However, do not think that metallurgy is all about ferrous products and its alloys only. There are many important standards and applications of non-ferrous products as well. A total number of 215 standards have been formulated in the non-ferrous sector, comprising of aluminium, copper, zinc, tin, nickel, lead, titanium, etc. These standards are used for manufacturing of various electrical and food packaging products, corrosion protection and other applications. Now let us hear from Sri Ashok Kumar, Scientist BIS, about some of the prominent standards in non-ferrous metallurgy.
Let me tell you about some of the important standards in the category of non-ferrous metallurgy. The standard IS 15392 for aluminum and aluminum alloy bare foil for food packaging specifies the requirement of aluminum foil used for food storage and packaging. The standard contains the requirement of pinhole count, preferred thicknesses, dimensional tolerances, foil response to stress, and test of surface condition of the product for safe packaging and prevention of food from contamination. The standard IS 12444 for continuously cast and roll electrolytic copper wire rod for electrical conductors covers the requirement of electrical conductor grade copper rod up to 18 mm in nominal diameter, produced by continuous casting and rolling for electrical round and rectangular conductor. The standard IS 21 for wrought aluminum and aluminum alloys for manufacture of utensils specifies the requirement of various grades of wrought aluminum and aluminum alloy sheets and strips used in the manufacture of aluminum utensils. The standard contains the requirement of bend test, tensile test, and supply condition of grade of material used for making utensils. Another standard IS 13923 for lead seal specifications covers the requirements of the lead seal for sealing purposes. It specifies the requirement of chemical composition, method of sampling and flattening property of the lead seal. For guidance purposes, the standard also specifies the typical dimensions for the lead seal used for sealing purposes.
I hope by now you know about the standards of many products made out of metals and their alloys that are used in our day-to-day life. Now let's talk about standards relating to various processes of metallurgical engineering. One such process is welding technology. Welding is a metal joining process and is used in fabrication industry. Welding electrodes are used to fuse two metal pieces together. Depending upon the process of welding, the electrodes are either consumable or non-consumable. BIS has formulated 111 standards in the welding category relating to jointing processes, materials and equipment used in jointing, training and safety of personnel, recommended procedures, method of tests for joining two or more similar or dissimilar metals by use of heat, pressure or both. Let us now know about some of the prominent standards in this sector from Shri Ram Sai Kumar, Scientist BIS.
I am going to give the brief introduction of important standards in welding technology and applications. In this category of welding technology, the Indian standard IS 814-2016 specifies the requirements for covered carbon and carbon manganese steel electrodes, including hydrogen controlled electrodes for manual metal arc welding of mild and medium tensile steel, including structural steels, and depositing weld metal having a tensile strength not more than 16 MPa. The requirements include tensile strength, elongation, impart properties, dimensions and tolerances, chemical analysis and bend test. The standard also gives the information of weld slope, position and rotation. The Indian standard IS 6901 for gas welding equipment specifies requirements for single and two-stage pressure regulators without flow metering devices for connection to gas cylinders used for compressed gases up to 300 bar, dissolved acetylene, liquefied petroleum gases, methyl acetylene, propadiene mixtures and carbon dioxide. For use in welding, cutting and allied processes, typical processes using this equipment are tungsten inert gas arc welding, metal inert gas arc welding, metal arc active gas welding, plasma arc welding, tubular core wire welding and plasma cutting. Another standard IS 6419 prescribes the requirement of solid filler rods and wires for structural steels by inert gas tungsten arc welding (TIG), gas metal arc welding or CO2 welding process. The chemical composition and mechanical properties of the filler wire and the rods are also specified. IS 6419 provides information regarding dimensions and tolerances of the wires, rods, spools, rings and coils. Also prescribes mechanical properties requirements, tests for filler materials and chemical composition of the filler rods and wires.
Well, that was quite interesting to know, and I'm sure that the information disseminated here will be of tremendous value to you. Now let us move on to the Foundry Technology category. Indian standards formulated on Foundry Technology comprises of 165 standards on metal castings for various applications and materials used for casting, such as foundry sands, mold boxes, patterns, cores, etc. Now let us hear from Shri Saqib Rahi, Scientist BIS, about some of the prominent standards in Foundry Technology.
Let me tell you about some of the important standards in Foundry Technology category. IS 8329 for centrifugally cast ductile iron pressure pipes used for water, gas and sewage applications. This standard stipulates the requirements for tensile test, hardness test, hydrostatic test, dimensions and tolerances. The standard also specifies the requirements of coatings applied externally as well as the linings applied internally on the pipes. The standard IS 1879 for malleable cast iron pipe fittings covers requirements for 14 types of threaded malleable cast iron pipe fittings for general purposes for the transmission of fluid and gas up to the certain limit of pressure and temperature specified in this standard. This standard stipulates the requirements of pressure test for leakage testing and compression test to judge the malleability of the pipe fittings. The Indian standard IS 9139 for malleable iron shots and grits for the use in foundry stipulates the requirements of malleable iron shots and grits as short blasting machine abrasives. The standard covers the requirements of designation of the size of the grits and shots based on proportions that are retained and passed through sieves. It also mentions the requirements of chemical composition, hardness, microstructure characteristics and specific gravity.
After Foundry Technology, now let's talk about testing of materials. It's quite interesting to know that BIS has formulated standards on testing of metals too. 357 standards have been formulated in this category covering mechanical testing of metals, metallography, non-destructive testing, chemical analysis of metals and code of practices on sampling and sample preparation. Now let us hear from Sri Akshay Kaushik, scientist BIS, about some of the prominent standards on testing of metals.
In the category of testing of materials by destructive and non-destructive methods, the Bureau of Indian Standards has published many standards. IS 1608 Part 1 is the specification for tensile testing of metallic materials under room temperature. Tensile properties of materials such as yield strength, tensile strength and elongation are useful to determine their mechanical performance, vis-a-vis furnishing limits for designing structures. Tensile strength is measured by elongating a specimen in a UTM, that is, Universal Testing Machine. Methods of closed loop and open loop for carrying out the test have been specified in the standard. The shapes and dimensions of test pieces are also defined in this standard. In this method, the specimen is held on the opposite ends using the clamps with one of the ends remaining stationary, while pulling the other with real-time monitoring of the forces. IS 3658 is the standard on the code of practice for liquid penetrant flaw detection test. Liquid penetrant process are non-destructive testing methods for detecting discontinuities that are open to surface. They may be effectively used in the inspection of both ferrous and non-ferrous metals and on non-porous, non-metallic materials such as ceramics, plastics and glass. Surface discontinuities such as cracks, seams, laps, cold shuts and laminations are indicated by these methods. The standard mentions about types of penetrant, selection of penetrant, surface preparation, developing, inspection and interpretation of the test results. Another standard in this category is IS 228 Part 1 to 24, which stipulates the volumetric, gravimetric and instrumental method for determination of different constituents in steel such as carbon, manganese, phosphorus, nickel, chromium, molybdenum, silicon, sulfur, arsenic, copper, tungsten, nitrogen, oxygen, etc.
Gold has fascinated Indians from ancient times for reasons of its intrinsic value and reverence attached to it during auspicious occasions. Gold is also a popular investment choice for majority of the population. In order to protect the consumer against any adulteration of gold and gold jewelry, Bureau of Indian Standards has started hallmarking scheme of gold jewelry in the year 2000 that guarantees the purity or fineness of gold jewelry and gold articles. The hallmarking scheme for silver and silver articles was later introduced in the year 2005. 61 standards have been formulated in this category covering gold, silver, platinum and their alloys and diamonds, including methods of assaying precious metals, recommended practices for manufacturing, requirements to assess competence of hallmarking centers, etc. Sri Akshay Kaushik, scientist BIS, gives us more details about some of the prominent standards on precious metals.
Now let me briefly describe some of the important standards in the precious metal category. IS 1417 on gold and gold alloys for jewelry or artifacts specifies, based on gold content, grades of fine gold and standard gold used for manufacture of bullion and coins, and grades of gold alloy used in manufacture of jewelry or artifacts. This standard also specifies the guidance for marking of purity and other details on tested bullion, coins and jewelry or artifacts. Similarly, IS 2112 on silver and silver alloys, jewelry or artifacts specifies 3 grades of fine silver and 6 grades of silver alloy used in the manufacture of jewelry or artifacts of silver based on their silver content. This standard also specifies the guidelines for marking of purity and other details on tested silver jewelry or artifacts. IS 15820 covers general requirements for competence of assaying and hallmarking centers such as management requirements, technical requirements, list of equipments and reagents for assaying of silver as well as gold and hallmarking of gold or silver jewelry. Next standard, IS 15766, is covered in 2 parts. The first part of this standard specifies the terminology and classification that shall be used for the grading and description of polished diamonds. The second part of the standard specifies test methods for grading of natural unmounted polished diamonds within the grades D, that is exceptional white plus, to grade Z, that is tinted series, as well as the grading criteria other than for the color of naturally colored diamonds.
After the precious metals category, let us now know about the standards formulated in the segment of refractories and powder metallurgy. A total number of 156 standards have been formulated in this category, covering refractories used in various furnaces and ladles and metallic powders produced through powder metallurgical route for various applications. These standards also include methods of sampling, physical tests for determination of properties of refractory materials and metallic powders. Now let us hear from Shri Dushyant Havelikar, Scientist BIS, about some of the prominent standards of this sector.
In the category of refractories and powder metallurgy, we have published many standards like the standard IS 2042 for insulating refractory bricks stipulates the requirements of refractoriness under load in order to cater to the use of insulating bricks as load-bearing component in furnace lining. Based on the suitability of the refractoriness under load at desired temperatures, refractory bricks have been classified into 3 grades. Grade A is suitable for temperature up to 1500 degrees Celsius. Grade B is suitable for temperature up to 1250 degrees Celsius. Grade C is suitable for temperature up to 850 degrees Celsius. The Indian standard IS 8370 specifies requirements for iron powder for use in the manufacture of sintered bearing and parts. The standard specifies 2 grades of iron powders, complying with the requirements stipulated for physical properties comprising of apparent density, size distribution on basis of sieve analysis, compressibility and flow rate.
It's also quite interesting to know that BIS has formulated standards of steel products that are coated with metallic coatings. These coatings protect the product from corrosion and give them a higher shelf life. A total number of 119 standards covering corrosion, passivation and protection of metals, characteristics of protective and decorative metallic coatings applied by electrolysis, anodizing or hot dipping have been formulated. Let's hear from Shri Vishal Kumar, Scientist BIS, who describes some of the prominent standards in this category.
In the metallic coating category, BIS has published many standards, out of which we shall describe some of the important ones here. The standard IS 12594 specifies requirements for zinc coating applied by hot dip galvanizing on structural steel bars. Some of the important requirements covered in the standard are quality of zinc to be used for coating, mass of zinc coating on the bars and adhesion of galvanized coating. The Indian standard IS 3203 is a test method standard, and methods prescribed in this standard cover procedures for measuring local thickness of electroplated coatings of copper, brass, nickel chromium, lead, zinc, cadmium, silver, gold and tin using various methods such as macroscopic method, magnetic method, BNF jet test method and stripping method, etc. The standard IS 8062 deals with the general principles and requirements of cathodic protection system for prevention against corrosion of external underground buried surface of metallic high pressure hydrocarbon product pipeline and structure. This standard is intended to serve as a guide for establishing minimum requirements for control of external corrosion on pipeline and structure system. Corrosion control by a coating supplemented with cathodic protection should be provided in the design and maintained during service life of the pipeline or structure system. You are welcome to have more details on the standards discussed here on our standardization portal eBIS.
We hope by now you've got enough information about the Indian standards that are being formulated by BIS in the area of metallurgical engineering. BIS is in the process of formulating new standards to meet the latest challenges of changing technologies. Let's hear from Sri Surya Narayan, head of the Metallurgy department, about the standards being formulated in emerging areas.
In pursuance of catching up with trends in emerging technologies, Bureau of Indian Standards has formulated standards relating to electro-galvanized steel sheets, refined gold and silver bars for good delivery, and is currently in the process of formulating standards relating to wear and abrasion resistant steel, armor steel, triple clad material, and induction tempered spring steel wire. Standard formulation plays an important role in the economy of a nation, and it is therefore a continuous exercise to update the existing standards and to formulate new ones to meet the challenges of changing technologies.
The BIS e-governance portal, Manak Online, provides a comprehensive view of its activities including on standardization. This portal serves BIS Technical Committee members and also other users of Indian standards. Filters to view the aspect-wise Indian standards classified based on test methods, product specifications, codes of practices, etc. is also available. The list of Indian standards relevant to various ministries and departments can also be accessed online. Details of published Indian standards and draft standards open for public commenting are also available. Proposals can also be submitted through the portal to make new Indian standards. Details about the technical committees, members and their affiliations through Manak Online are just one click away.
We are sure that the information disseminated in this program will be of immense use to you. With an eye on technological changes and developing standards in times to come, the future looks safe and bright for the country. BIS, an organization in the service of nation.